Hi students, welcome back. In today's video, we'll be tackling a classic problem of valid palindrome. Let's go over the problem statement first. So here, first they gave the definition of what is a palindrome. So a phrase is a palindrome if after converting all the uppercase letters to lowercase and removing all alphanumeric characters. So basically, just the string remains, nothing else. If it reads the same forward and backwards, then it is called a palindrome. So we are converting uppercase letters to lowercase letters. That means it is not a case sensitive match. Okay. And we are removing all non-alphanumeric characters. Alphanumeric is which includes letters and numbers, which means we remove anything which is not a letter or a number. Okay. In, After processing the string like that, in the resultant string, if it reads the same backwards and forwards, which means if it is a mirror image from the center, then it is a palindrome. We have to return true. Otherwise, it is not, and we return a false. Let's go over the examples. So, in the first example, it says a man, a plan, a canal, Panama. After removing all the special characters, this is the string, and it reads the same forwards or backwards. So, it is a palindrome. In the example 2, we have race a car. After removing all the characters, this is what we are left with. The middle two characters, they are not equal, so this is not a palindrome. The third example says it's an empty string. Once we remove special characters, non-alphanumeric, which is space, we are left with only empty string. Empty string is same forwards or backwards, so this is a palindrome. So let's go over the solution with an example. Let's say we are given this string. Okay. So after we remove all non-alphanumeric characters. So colon space is non-alphanumeric, colon is not alphanumeric. And converting all uppercase to lowercase. Here A is uppercase. We convert it to lowercase. Okay. This is the process string we have. So let's take two pointers for this approach. A left pointer and a right pointer. Since we are comparing strings at both the ends, let's take two pointers and compare if if the characters are same at both the ends. How long will we do? As long as left is less than right. Once left is greater than right, that means we have moved to the other end of the string, and since we already compared, we need not do it again. Okay. So we start here. Both left and right are at character T, both are same. So we increment left and decrement right. So now both left and right are at A, both are same. So we increment left and decrement right. Both left and right are at C. So we continue, we increment left and decrement right. Since left is not less than right, we return at this point. Since all the processed characters are same, so this is a palindrome. We do have O at the center, but it is just one character. So it is still a mirror image from each other. Whether you read from this side or this side, it is taco cat. So this is a palindrome. So now let's check another example. Let's say we have this string. Okay. Here, if we remove all the non-alphanumeric characters and convert all uppercase letters to lowercase. Here we don't have any, so we don't have to do that. This is the string we are left with. Now again, let's take two pointers like before. One which represents left and the other which represents right. We have T at both the places. So let's increment left and decrement right. So we have A at both the places. Let's increment left and decrement right. Now at this position, we have K at left and C at right. Both are not equal. So this is not a palindrome. Okay. So let's write code for this problem. Okay. So first we have to process the given string. So we have to remove all non-alphanumeric characters. For that, we will use a function called replace all, which will basically replace all the matching regex characters with whatever is given. So we have to just remove them. So we will replace with an empty string. So what is not allowed? Anything which is not, this symbol is for not alphabets. Alphabets are small letters and capital letters, and anything which is not a number. This is not because we are using this symbol caret. Okay. Anything which is not this, we replace with an empty string, and we also have to convert all of them to lowercase. Okay, so now we'll have the process string. Then what do? We take two pointers, left and right. Okay, so left is at start of the string, right is at end of the string. How long we process the string? We process it as long as left is less than right. What do? If s dot caret left is not equal to s dot caret right, okay, we return false. If both are not equal, there is no point processing further, so we just return false and exit. If both are equal, then we increment left and decrement right. And once we leave the loop, that means we have processed everything and everything is equal, then we return true. Let's run this and see. Okay, let's submit this. Okay, so it ran, it is accepted. It took 21 milliseconds. Let's check the time and space complexity of this problem. Okay, what is the time complexity? So the replace all section, it takes order of n time to process over the string. Okay, then these are all constant operations. This loop takes order of n by 2 times. But since constant is not important in the big O notation, it is still order of n. So order of n plus order of n, order of 2n, which is again order of n. Okay, where n is the size of the string. What is the space complexity? So in the actual business logic, we are not using any extra space, just these two pointers. So for the business logic, it's just order of one, no extra space. But the replace all function internally uses the size of string memory. So the space complexity here is not constant but order of n. Usually everyone thinks it's constant because we tend to ignore the library functions, but when you are computing space complexity, everything is important. So the space complexity is order of n for us. Okay. Alright then. Thank you for joining me in this tutorial. I hope you now understand how to find complexity of a problem by carefully looking at every line. Even if it's a library function, it still contributes to the time and space complexity. Okay. Remember, practice makes perfect. So keep coding and improving your problem solving skills. If you have any questions, please leave a comment on the video. If you found this video helpful, don't forget to like, share and subscribe. Happy coding!